Hello and welcome. In this lecture video, I'll continue the discussion of compound interest calculations and also talking about how to calculate the present value and future value of a single amount. Okay, so where we left off last time was talking about suppose we issued a $1,000 10% 3-year note payable. We went over simple interest calculations and then we looked at compound interest, and recall the difference between compound and simple is that with compound interest we are earning interest on top of not just the principal, but also the interest. In this case, we're not earning, we're paying because it's a note payable. Okay, so that was, if you look over here, this is on an annual basis. Let's take a look at this exact same problem, but we have compound interest is calculated, or I'll use the term compounded, semi-annually, so every 6 months. In that case, what we actually have to do is we need to adjust our formula a little bit. We need to adjust our table, I'm sorry. So we'll set up and we'll say period, and then we'll say interest, and then we'll say future value. And I'm going to do the first year and a half of this calculation, and just to give you an idea of what's going on, and I think that gives you the gist just because I'm running out of room here. Okay, so what I can say is in the first 6 months, why is it 6 months? Because it's semi-annual, so every 6 months it's going to compound. So what we'll do is we'll take our $1,000 and then we'll multiply it times 0.1, which is our yearly interest rate. Remember this 10% right over here, this is 10% per year. So since we're compounding it every 6 months, I'm going to multiply it times my 0.1, but I only have it for 6 months, so I have to multiply that times 0.5. What I could also do is just take a shorter cut and take 1,000 times 0.05, and I'll get the same answer. And that's $50. So then at the end of my first 6 months, my future value is $1,050. Then I can come over here to my second 6 months. I'll take my $1,050 and I'll do the exact same thing. And I'm just kind of writing out times 0.1 times 0.5 rather than times 0.05 just to give you the full explanation of what's happening. But know that you could just go 1,000 times 0.05 because 0.05 is the same thing as 0.1 times 0.5, taking half of 10%, 5%. Times 0.5 gives me my 5250. Then when I add that to my 1,050, 1,102.5. And then here's where I'll end, because I think you get the gist after this. I'll take my 1,102.5 times my 0.1 times my 0.5, 55, and then it gives me right over here 1,057.625, and then I continue this all the way through 3 years. Okay, so you would have some more periods here all the way up until 3 years. So you would have total of 6 periods. Okay, and so then at the end, when you do that, and I would encourage you to do that, and just to check your work, that should be your total future value right there. Okay, so let's come back over here and let's look at this formula that we were talking about earlier. And let's talk about it in terms of our compound interest. Because as I was saying earlier, in terms of future value and present value, we're really referring to compound interest and not simple interest. Okay, so what I can do is with this table right over here, I can represent this table mathematically with a formula, where I can say FV, or in this case, I'll put a a V there, just to be consistent. So PV and FV. It's the same thing. I just called it P or F. Here I'll call it FV. Future value equals my present value times 1 plus I to the n power, where I equals my interest rate and n equals the number of periods. So I equals my interest rate and n equals my number of periods. Okay? So that's the same thing. If you look over here, what we're doing is we're really just saying FV equals PV times 0.1 times 1.1, so on and so forth, all the way up to the n power. So this is just our mathematical formula, which represents what's going on in this table. So if this is true, FV equals PV times 1 plus I to the n power, I can do algebra and I can do my present value formula, which is equal to present value, therefore equals my future value, divided by 1 plus I to the n power, which is this formula right there. Okay? So, if we were to use this formula to solve the problem, right, we could come down here and we could multiply, we could take our 1 plus 0.1 to the third power, okay? So following our formula up here, FV equals PV times 1 plus I to the n, 1 plus 0.1 to the third power. N is the number of periods, 0.1 is the interest rate, so 1,000, which is my present value, equals my future value. And I can show you that right over here in terms of Microsoft Excel. I have my present value right there. Here's my interest rate. Here's my number of periods. And then what I do is I do a formula that says 1 plus the interest rate to the third power. That gives me that factor. It's called my factor, right? And that's 1.331. And then what I can do is multiply the present value of 1,000. You can see the reference, K4, K8, K4 times K8. I can multiply the $1,000 present value times my factor, and then that gives me my future value right there. Okay? Okay, so let's look at the formula applied to semi-annual. So I have my 1,000 times 1 plus I to the n power. 1,000 present value times 1 plus 0.05, because remember the interest rate is 10%, but it's 10% per year, which means it's 5% every 6 months. N is no longer 3, it's 6 because there's 6 is semi-annual for 3 years, so 6 total periods. And then that gives us our 1340.09. When I do it in Microsoft Excel, I have 1340.1. It's just off by a little bit due to rounding. But see, I have my 1,000, and then my interest rate is 0.05, 6 periods. Here's my factor, and then I multiply the 1,000 times my factor, and then I get my answer right there. Okay? So when we answer these questions, what is the future value? Well, we've done, it's 1,340.09 when we're looking at semi-annual compounding. But with annual compounding, it was 1,331. With simple interest, it was 1,300. In terms of what is the present value, it's the $1,000. Okay? The $1,000 principal of the note payable. Now, when we're solving these problems on the test and in this class, all right, you can use the formula. If you have a financial calculator, you can use that too. But what I'm going to do with the exams is I'm going to include the tables in your Appendix B in the textbook, or they will be included with your exam. And then there's 4 tables at the end of your Appendix B. There is the present value of a single amount, the future value of a single amount, the present value of an annuity, and then the future value of an annuity. And I want to take a look at the future value of a single amount table right now. So this table is table B.2, which is in your Appendix B, okay? And what this table shows you are those factors. And these are the factors that we calculated with 1 plus I to the n power. So basically what these factors are, is 1 plus I to the n power. So remember, when we did 1 plus I to the n power, where I equaled 10%, and the number of periods equaled 3, and we got 1.331. That's what this is. We used the formula to get that 1.331, and then we multiply it times the $1,000 present value to get the future value of $1,331. So what I could do is I could take a shortcut from using the formula, basically. I don't have to use the formula. I can use this table, because this table is basically 1 plus I to the n power, and it's giving you the factors for you to make it easier for you. And this is what I was saying. This is what I will include with your exams. And this is how I will review present value and future value. The rest of this chapter is using these tables. So if we look at again, the way we use these tables, we find our interest rate, and then we look across at our number of periods, and we find our factor, and then we multiply this factor times the present value to get the future value. So here, 10%, 3 periods, 1.331. What about when we did it semi-annual? Remember, a semi-annual, it was 5%, and then how many periods? Well, it wasn't 3 because it's 3 years semi-annual, so 6, 1.3401, and what we could do is multiply 1.3401 times our present value of $1,000, and then that gave us our future value. So basically, this is what will be included in your exams. This is how I will go from here on how to calculate present value and future value. And this is table B.2. If you look up, you see table B.1, which is the present value of a single dollar. And then on these other 2 pages, we talk about table B.3 and B.4, which are the present value of an annuity and future value of an annuity. Okay? So if we look at this problem, this is pretty similar to the problem that we just did, but it's in the case of a deposit. If you deposit $1,000 now and leave it for 3 years, how much would you have at the end of 3 years? So I'm asking for the future value, and I'm saying 10% compounded annually. So how would you solve this problem using the table? You would look in the table, and I want you to pause the lecture video, and I want you to look in table, the future value of a single amount, find the appropriate factor, multiply the factor times the present value, just like what we did up here, and then let's check your answer. Okay, so this is what you should have gotten. Future value, a single amount factor, 10%, 3 periods. You look in the table, the factor is 1.331. You multiply the $1,000 present value. How do I know that's the present value? Because it says if you deposit $1,000 now. That's keying me into telling this is the present value. Present value times my factor, which is 10%, 3 periods or 3 years, gives me the 1,331, which is the future value. Okay? I'm going to go ahead and pause this lecture video now and pick up on the next page talking about present value and then some other problems as well. Thanks.